Now, let's use some of the properties of transformations to complete some of the transformations, including reflections, translations, and rotations. We'll start with number 1. Draw the line of reflection, then write a rule to describe each reflection. We won't do all of them, but we'll start with this one right here. In this example, we have our pre-image and our image. I know the difference because our pre-image has the letters I, T, G, and F, while our image has these little apostrophes after each of the letters. They're pronounced I prime, T prime, G prime, and F prime. So that's our image and our pre-image, our starting point and our ending point. So then, we know this is a reflection, but we need to draw the line of reflection. Remember one of the properties of reflections, that the line is going to be the bisector of these two images, meaning it's halfway in between. So what I can do is count between corresponding points. For example, from I to I is 1, 2 spaces. So halfway is 1, so the midpoint is right there. Between F and F prime, it's 1, 2, 3, 4. Half of 4 is 2, so 1, 2, and there's the midpoint right there. Let's do one more. Between G and G prime, it is 1, 2, 3, 4, 5, 6, 7, 8 spaces, and so halfway is 1, 2, 3, 4. Midpoint is right there. Notice how all of those midpoints are lining up on the same line? That line will be the bisector, halfway between those two images, and there's my line of reflection. Once you've drawn that, the next question is how do we notate that? How do we describe that line we've just drawn? Well, first we use a small r to show that we're doing a reflection. Then we've got to think about how do I name this line? Well, that line we've drawn is the x-axis, so we'll write x-axis as a subscript, kind of smaller down below the r. And then lastly, we'll add some parentheses with the points that I am transforming or reflecting here. So I reflected I, T, G, and F to get this new image, so I'll write down I, T, G, F. So again, this says reflect over the x-axis, I, T, G, F, and that's exactly what we've done here. Next, let's take a look at this one right here. Now, this one can be a little confusing because the two figures, both the image and the pre-image, are kind of overlapping, on top of each other. To help myself out, I'll grab a couple highlighters, and I'm going to highlight the pre-image in green. Again, that's the one without any of the apostrophes. So A, R, D, C, and back to A. The image will be the one with the apostrophes that are called prime. So here's A prime, R prime, D prime, C prime, back to A prime. And now you can kind of see what's going on here. It looks like the green pre-image has been reflected over to the red image, but where's the line? Well, again, we know that the line of reflection is the bisector of the two images, halfway in between, so let's find where halfway is. From D to D prime, it's 1, 2, 3, 4, 5, 6. Half of 6 is 3, so 1, 2, 3, there's the midpoint. From R to R prime, it's 1, 2, 3, 4. Half of 4 is 1, 2. There's midpoint. And let's go from C prime to C. 1, 2, 3, 4. Half of 4 is 2. There's the midpoint. Again, they're all lining up. I'll draw this bisector here, cutting that in half, and there's my line of reflection. Now, again, how do we describe that? How would you describe that? Well, again, I'll use the small r to notate that I'm doing a reflection. But now this isn't the x-axis, and it's not the y-axis either. So how do I describe that line I've just drawn? Well, it's going through the x-axis at the point 1, 2. And if you remember from Algebra 1, a vertical line has the form x equals, and again this is going through 2, so x equals 2. And again, the parentheses with the letters that I'm actually reflecting, which will be, let's see, R, A, C, D, R, A, C, D. All right. There's that one. Let's take a look at this one right here. This is probably one of the more challenging ones on the page, so let's try that one together. Alright, so this one's a little trickier. We've got our pre-image here, S-A-Q-T, and our image, S prime, A prime, Q prime, T prime. So where's the line of reflection going to be? Well, remember, it's got to be halfway in between the image and the pre-image. It's got to be a bisector. So let's look at maybe S and S prime. If I count on this diagonal here, it's 1, 2, 3 diagonal units away from each other. Half of 3 is 1.5, so let's go 1.5 diagonal units away from each other. There's my midpoint. What about Q? 1, 2, 3, 4 diagonal units. Half of 4 is 2, so 1, 2 places me right there. Let's do A. 1, 2, 3, 4, 5, 6, 7, 8 units between A and A prime. So let's go 4 diagonal units. 1, 2, 3, 4. There's midpoint. And again, they're all lining up. All my midpoints are lining up on the same line right here. I'll draw that bisector. And now I've got my line of reflection. But how to describe it? It's not an x-axis or y-axis. It's not even any vertical or horizontal line. What is it? Well, let's start with the little r for reflection, because we know it's a reflection. But then, what are we doing from there? Let's see. This line goes through the y-axis at 0, and it looks like it's got a slope of down 1 over 1. So it's got a slope of negative 1 over 1. So I could write this line, y equals negative 1 over 1x plus 0, but it might be easier just to write it as r and then y equals negative x. Right? So that's the line I'm reflecting over. This is the line y equals negative x. And again, we'll add the points there, a, s, t, q, and there it is. That's how you describe that line. That is the line y equals negative x. In case you're ever unsure if you've made the correct line of reflection, here's what you can do. Take a piece of transfer paper, like this one right here. Okay, it's this translucent paper, and put it on top of your grid. Trace your pre-image, as I'm doing right here, okay, and also your line of reflection. Then, take your transfer paper, lift it up, flip it over, and place it back down so that the line of reflection lands back on itself. Hopefully, if you've done this correctly, you should have your pre-image land on your image, and your line of reflection should be in the same place. If this works, then you've created your reflection properly. So what if your reflection doesn't have a grid or a graph on it like these two? Well, there's two ways to handle that. The first way is by using a ruler, and again, thinking about the properties of reflections. We know that the line of reflection is the bisector of the pre-image and the image. So it makes sense to just find halfway in between where those two images are. Using centimeters, looks like I've got about 5 centimeters between the top tip of both of these triangles. So that means if this is 5 centimeters, the midpoint will be at 2.5. Make my point right there. Between these corresponding parts, it's about 7.2 centimeters. So half of 7.2 is 3.6 right there. There's my halfway. Okay, and another pair of corresponding points will be between, let's see, these bottom points right here, 0 and looks like 2.6. Half of 2.6 is 1.3, so right there. And notice how all of those points line up. That is the bisector, the line of reflection between those two triangles, and there you have it. The other way we could do is with one of these mirrors right here, right? All you've got to do is take one of these mirrors and take this beveled edge, this kind of pointy edge right here, and put that down on the paper like this, okay? And then look through this side. What we're going to try and do is look into this mirror right here and move it until the image and the pre-image in the mirror line up. Just a little bit of a better view, so we're going to try and line that reflection up right about there, okay? And then we'll hold our mirror and draw that line right there, and hopefully you have a line of reflection halfway in between the pre-image and the image, serving as that perpendicular bisector. Let's take a look at number 2. Draw the vector for each translation, then write a rule to describe each translation. More specifically, let's take a look at the second example here to do together. Now when it comes to translations, there are 2 properties we'll need to remember. The first one is that every translation can be represented by a vector, and a vector has direction and distance. So to get from G to G prime, we've got to think about the direction. We'll have to go down and to the right. We'll also have to think about the distance. We're going down 1 and to the right 2 spaces. The second thing to remember is that every vector is the same length and moving in the same direction. They're parallel. So we can double check that every vector from the pre-image to the image, from n to n prime, is going down 1 to the right 2. From m to m prime, down 1 to the right 2. Now we're ready to notate this. For translation, we use a capital T, followed by the vector we moved in. The first number, just like with a coordinate, will be how far we moved in our x direction. That's left to right. We've moved 2 to the right, so it'll be positive 2. The second number tells us how far in the y direction we moved, up and down. We've moved 1 down, so that'll be negative 1 in the y direction. And again, that'll be followed by the points of the pre-image that we translated, G, N, M. G, N, M. Remember, the most important things about this example are, number 1, every vector is represented by a direction and a distance. Number 2, every vector can also be represented by this ray right here, right, almost like an arrow. And lastly, all the vectors from the pre-image to the image should all be parallel and the same distance. So they should be going in the same direction and have the same distance. Or really, they're all the same vector. Down 1 to the left, to the right 2. Let's take a look at these examples here with 3. Draw the center and 1 angle for the rotation. Then write a rule to describe each rotation. Let's focus on this second example right here to do together. Now when we're doing a rotation, there are 3 things we need to keep in mind. First, where is the center of the rotation? What is it spinning around? Second, what direction is it going in, clockwise or counterclockwise? And third, how far is it going? How many degrees? What's the angle? So, to help us out, we're going to use a little bit of this transfer paper that we used earlier. Put that down on top of the second example here. And let's begin by tracing the pre-image, JPRY. Okay? And then thinking about, well, where's the center of this rotation going to be? In most examples we do in class, the center of rotation is going to be right at 0, 0, right here. So put a little dot there and do a little trace right here of the x and the y axis, just get all across there. And then to figure out how far and what direction we're going in, we're going to take our pencil and hold it down right here at the 0, 0, at the center of rotation. And we're going to try and spin this to get to the image. So it seems like I'm going to have to spin in this direction. And there, now it lines up again. So I've turned this transfer paper 1/4 of a turn, or 90 degrees. So I've rotated around 0, 0, 90 degrees, but what about the direction? Well, I moved from the pre-image to the image, I moved clockwise, 90 degrees clockwise. When writing this as a degree measure, clockwise rotations will always be negative. So, if I wanted to notate this rotation, I would write a capital R for rotation. Then I would write negative 90 degrees to show that I have moved 90 degrees clockwise. That's where the negative comes from. And then I will write the center of rotation, which is 0, 0. It's the point my pencil was on, right? And then, in large parentheses, I will write down what I've rotated. JYRP. JYRP. Now there is another way to write this. Remember, when I rotated from my pre-image to my image, I moved 90 degrees clockwise. But what if I started here with my image again, or my pre-image, I held my pencil down at 0, 0, and I rotated 90, then 180, then 270 degrees around the origin. I still get to my image, but this time I rotated counterclockwise, 270 degrees. That's okay. Another way to write this is a rotation of positive 270 degrees, because when I'm rotating counterclockwise, we consider that to be the positive direction. Again, around 0, 0, and of the same points, J, Y, R, P. So either one is acceptable, and in fact, it might help you to write both of them out. So the 3 things to think about when you're doing a rotation are, number 1, where's the center, where you're putting your pencil? Usually it's 0, 0. Number 2, how far are you rotating? Is it 90, 180, 270 degrees? And lastly, what direction? Clockwise is negative and counterclockwise is positive.